So welcome, this is part 2 for the video for integrals kinematics for AAHL. So in part 1 we did up to question number 26. Now from question number 27. A ball is dropped vertically from a height. Its velocity is given. Find the value of v when t equals to 0. So we have to find it out the value of velocity when time equals to 0. So for that, what am I going to do? I am going to substitute just value of t, which is equals to 0 over there, and we should be getting that answer for that. So part A, v0 equals to 50 minus 50 e power 0, which is going to be 0 itself. Next, at t equals to 10. So for part 2, v10 equals to 50 minus 50 e power negative 2. Do by calculator, you should be getting 43.2. Now for part B, find an expression for an acceleration and what is the value of a when t equals to 0. Acceleration is nothing but what? dv upon dt, which is nothing but what? Negative 50 times minus 0.2 e to the power of minus 0.2 t. So which is 10 e to the power of minus 0.2 t. Now acceleration of 0 should be equals to 10 e to the power of 0, which is going to be 10. That one was for part 1 and part 2. Now coming to part C, as t becomes large, what is the value v approaches? T becomes large, what value dA approaches? Explain the relationship between part 1 and 2. So as t is approaching infinity, very large value, we can see that we will be approaching 50, because what will happen is 50 e power minus 0.2 t will be approaching to 0. It becomes 0. So 50 minus 0 is going to be nothing but how much? 50. For acceleration, it is as t approaches to 0, it becomes acceleration approaches to 0, because 10 e to the power of minus 0.2 will be approaching to 0. So acceleration will be approaching to 0. So when acceleration equals to 0, there is no acceleration, velocity will remain constant at 50. That's going to be the answer. D. Let y meters be the distance fallen after 3 seconds. Show that y is this much. So what is the condition for finding y? Y is nothing but what? The distance or the displacement. So it is integral of v dt. So which is 50t minus e to the power of minus 0.2 t divided by minus 0.2 plus k. So what does that becomes? 50t plus 250 e to the power of minus 0.2 t plus k. Part 2, given that y equals to 0, t equals to 0, find the value of k. So for part 2, what is that? 0 equals to 50 times 0 plus 250 e to the power of 0 plus k. So 250 plus k equals to 0. So k equals to negative 250. Part 3, find the time required to fall 250 meters, giving your answer in two significant figures. So 250 equals to 50t plus 250 e to the power of minus 0.2 t, then minus 250. So this gives me, use the calculator, you should be getting it out 9.207 seconds. Question number 28. In this question, S represents the displacement in meters, T represents the time in second. The velocity is given, A is constant. Given that S equals to 0, T equals to 0, find an expression for S in terms of A and T. So ds upon dt equals to 30 minus 80. So what will be S? S will become integration of that 30t minus 80 squared by 2 plus c. Now at t equals to 0, so that will be S will be 30 times 0 minus a times 0 square upon 2 plus c, which is nothing but what? 0 plus c, which should be equals to 0. So which gives me c equals to 0. So what is the formula for S? 30t minus half 80 square. Train approaching the station starts to slow down when they pass a signal of 200, which is 200 meters from the station. The velocity of train 1 t seconds after passing is given by this. Write down its velocity as it passes the signal. Show that it will stop before reaching the station. So for part 1, velocity will be 30 minus 5 times 0, which is going to be 30 meters per second. The train will stop, means distance should be equals to 0. So our velocity should be equals to 0. 30 minus 5t equals to 0 means t equals to 6 seconds. So distance traveled will be 30t minus half 80 square. So which is 30 times 6 minus half times 5 times 6 square, which is going to be 90 meters. And we know that the actual distance is 200 meters. So therefore 90 meters is less than 200 meters. Therefore train stops before station. Train stops before station. Part C, train 2 slows down so that it stops at the station. Its velocity is given by this one. Find in terms of A the time taken to stop. Use your solutions in part A and C1 to find the value of A. Now this also stops and the velocity for this one is going to be 30 minus 80. It should be equals to 0. So T equals to 30 upon A. Now for part 2, the distance is 30t minus half a t square. 30 upon a whole square should be equals to 200 because it is stopping at the station. So 900 upon a minus 450 upon a equals to 200, which is 450 upon a equals to 200. So a equals to 450 upon 200. So a equals to 2.25 meter per second square. Question number 29. A ball is thrown vertically upwards into the air. The height h meters of the ball above the ground t seconds is given by this. Find the initial height above the ground. So for finding the initial height, t should be equals to 0. So h equals to 2 plus 20 times 0 minus 5 times 0 square, which is equals to 2. For part B, show that the height of the ball after 1 second is 17 meters. So t equals to 1. So h equals to 20 plus 2 plus 20 times 1 minus 5 times 1 square, which is 17 meters. Then for part C, at a later time, the ball is again at 17 meters. Write down the equation. So 17 equals to 2 plus 20t minus 5t square. Then again, solve this equation algebraically. So what does it becomes? This one was part 1. For part 2, 5t square minus 20t plus 15 equals to 0. Take 5 common. T square minus 4t plus 3 equals to 0. T minus 3 times t minus 1 equals to 0. So we get t equals to 3, t equals to 1. Find dh by dt, find the initial velocity when the ball reaches maximum height and find the maximum height for part D. So what is dh upon dt? Equals to 20 minus 10t. For part 2, at time equals to 0, so dh upon dt should be equals to 20 minus 10 times 0, which is 20. For part 3, maximum means dh upon dt should be equals to 0. 20 minus 10t equals to 0, so t equals to 2 seconds. And for part 4, substitute t equals to 2, so h equals to 2 plus 20 times 2 minus 5 times 2 square, which is going to be 22 meters. Question number 30. The main runway of Concordville Airport is 2 kilometers long. Landing on Concordville touches down at a point T and immediately starts to slow down. The point A is at the southern end of the runway. The marker is located at point P. As the aeroplane slows down, its distance s from A is given by this formula. The aeroplane touches down at 800 meters from A. C equals to 800. Find the distance traveled by the airplane in the first 5 seconds after touching down. Write down an expression for the velocity of the airplane after touchdown and hence find the velocity after 5 seconds. For this, first of all, at t equals to 0, s equals to nothing but how much? 800, because it is touching down at a distance of 800. Now, at t equals to 5 seconds, I want at 5 seconds. So it will be 800 plus 100 times 5, I'm plugging in this, minus 4 times 5 square, which is going to be nothing but how much? 1200. So after t equal to 5 seconds, it has traveled a distance of this much. Now, actually, how much distance it has traveled? So, distance in the first 5 seconds. Distance in first 5 seconds will be 1200 minus 800, which is equals to 400 meters. It has traveled 400 meters. Write down an expression for the velocity. So for velocity, what should I be doing it out? When I know the distance, velocity equals to ds upon dt, which is 100 minus 80. At t equals to 5, what will be the velocity? 100 minus 40, which is 60 meters per second. The airplane passes through the marker at point P with a velocity 36. Find how many seconds after touchdown it has passed through. So, for part B, the velocity is 36 and the formula for the velocity was 100 minus 80. So, this gives me the t value as 8 seconds. So, after 8 seconds, it has done. What is the distance P to A? So, t equals to 8, s equals to 800 plus 100 times 8 minus 4 times 8 square, which is going to be 1344 meters. Show that the airplane touches down before reaching the point P. It can stop before reaching the northern end at B. What was the total distance? The total distance is 2 kilometers, which is 2000 meters. So in order to stop at P, we know that in order to stop at P, it has to travel a distance of 1344. So it has to travel a distance of 1344. If it touches at P, then 2000 minus 1344 is left over for it, which is 656 meters to stop. It has to stop in this much distance before reaching B. So in order to come to rest, how much time it is required? Velocity should be equal to 0. 100 minus 80 should be equals to 0. T equals to 12.5 seconds. What is the distance traveled in this 12.5 seconds? Distance in 12.5 seconds will be 100 times 12.5 minus 4 times 12.5 whole square, which is 625. So in this 12.5 seconds, it travels 625, but it requires 656 meters to stop. So 625 is less than 656. So it can stop safely because still it has 656 meters, but it will travel only 625 meters. So still 31 meters ahead it will stop. Ahead of B it will stop. So it is safe. Question number 31. A mass is suspended from the ceiling on a spring. It is pulled down to a point P and then it released. It oscillates up and down. Its distance s centimeters from the ceiling is modeled by the function s is equal to 48 plus 10 cos 2 pi t, where t is the time in seconds from release. What is the distance of P from the ceiling? We have to find the distance of P from the ceiling. So for that, what am I doing it out? And how long is it until the mass is next to the P? So when it is released means time equals to 0. So what will be the distance? 48 plus 10 times cos 0, which is going to be 58 centimeters. It is released from a height of 58 centimeters from the ceiling. Now Part 2. How long is it until the mass is next at P? So again, it should come back to 58. When is that? 48 plus 10 cos 2 pi t should be equals to 58. This gives me cos 2 pi t should be equals to 1. So what is that? Cos 2 pi t should be equals to 1. So we know that cos 2 pi equals to 1. Therefore, t should be equals to 1. So 1 second. Find ds upon dt. What is ds upon dt? Derivative. Sine cos derivative is minus sine. 20 pi sine 2 pi t. Where is the mass when the velocity is equals to 0? So minus 20 pi sine 2 pi t equals to 0. So sine 2 pi t equals to 0. So it can be at sine 0 or sine pi. Sine 2 pi t can be equals to sine 0. So which gives me t equals to 0, or else sine 2 pi t should be equals to sine pi. So this gives me t value as 1 by 2. A second mass is suspended on another spring. The distance is modeled by this function. The two masses are released at the same time. Find the value of t when they are first at the same distance before the ceiling. They should be at the same distance before the ceiling. So 48 plus 10 cos 2 pi t equals to 60 plus 15 cos 4 pi t. So use a calculator to solve it out. So which gives me t value as 0.162 seconds. Now finally to the part D. So how should I be able to solve it out? Part D. What is part D? In the first 3 seconds, how many times the two masses will be at the same height? In the first 3 seconds. How many will be at the same time? So how should I be able to do that? So when you use the calculator and keep the scale of the calculator or x value, then at up to 3 seconds, 3, you can see that there will be 12 points of intersections, 12 times. So keep the scale, what it says, of x maximum value as 3, then you can see that there will be 12 different solutions will be there. So therefore the answer is going to be 12, because this is by GDC. You can use this GDC to get that answer. Question number 32. A rock climber slips off a rock face and falls vertically. At first he falls freely, but after 2 seconds a safety rope slopes him down. The height h meters of the rock climber, t seconds of the fall is given by these two. During first 2 seconds is the formula, 2 to 5 is the formula. Find the height of the rock climber when t equals to 2. T equals to 2, find the height, which is 50 minus 5 times 2 square, which is going to be 30. Sketch the graph of h against t for 0 to 5 seconds. You can use the graphing calculator and your graph should be approximately equally coming it out in this way. Time t, and this is height h. Find dh by dt between those two values. So dh by dt will be negative 10t for the first one, and for the second part of the journey it will be minus 40 plus 10t. Find the velocity of the rock climber when t equals to 2. So for part D, t equals to 2, so dh by dt, I am going to use it out this one, minus 10t minus 10 times 2, which is negative 20 meters per second. Then find the times when the velocity of the rock climber is 0. So dH upon dt should be equals to 0. Minus 10t equals to 0. So t equals to 0. Or another way is minus 40 plus 10t equals to 0. So this gives me t equals to 4 seconds. This is for the value between t value lies between 0 to 2, and this value is t value lies between 2 to 5. Find the minimum height of the rock climber. Minimum height, so t equals to 4. So h equals to 90 minus 40 times 4 plus 5 times 4 square. Simplify that, this is going to be 10 meters. That's the answer. Question number 33. A Ferris wheel with center O and radius is 15 meters is represented in the diagram below. Initially, a seat A is at the ground level. The next seat is at B. Angle AOB is pi by 6. Find the length of the arc AB. We need to find the length of the arc AB and area of the sector AOB. Length of the arc is r theta, which is 5 pi by 2. Area of the sector formula is half r square theta, which is going to be 58.9 meters square. Or this is, if you want to write in three significant figures, 7.85 meters. The wheel turned clockwise through an angle of 2 pi by 3. Find the height of the above A. So what is happening? It's turning 2 pi by 3. It comes 2 pi by 3 over here. The wheel turns, find the angle, what is the height of A. So it has been turning 2 pi by 3. 2 pi by 3 means 120. 120. $90 and 120. It goes up to this position. Now that particular angle is 2 pi by 3. So obviously this angle will become pi by 6. That angle is pi upon 6. So this angle will be 90 degrees. And the total angle was 2 pi by 3. So the 90 plus pi by 6 is nothing but what? 2 pi by 3. So angle is pi by 6. Angle equals to pi by 6, which is 30 degrees. So height is going to be 15 plus 15 sine pi by 6, which is going to be 22.5 meters. The height h meters of the seat C above the ground after t minutes can be modeled by the function. Find the height of the C at t equals to pi by 4. So for this one, just plug in pi by 4. So it becomes 15 minus 15 cos pi by 2 plus pi by 4, which is going to be 25.6 meters. Find the initial height. Just substitute 0 over there. For that, it becomes 15 minus 15 cos 0 plus pi by 4, which is going to be 4.39 meters. Find h prime t. Or find the time at which the seat C reaches its first highest point. What is the highest point? Highest point is 30. So 30 equals to 15 minus 15 cos 2t plus pi by 4. Use the calculator. You should be getting it out. T value is 1.18. Find h prime t. What is the value for h prime t? H prime t is 30 sine 2t plus pi by 4. Sketch the graph of h prime. Find the time at which height is changing rapidly. The graph of h prime. It should be somewhere in this way. Pi by 2 and pi. and this is 30. Check that, it should be in that way. And part 2, find the time at which the height is changing most rapidly. Height is changing most rapidly, either maximum point of the h prime or the minimum point of the h prime. Maximum point occurs at 0.393, minimum point occurs at 1.96. Question number 34. The velocity v meters per second of a particle at t seconds is given. Write down the velocity of the particle at t equals to 0. Just plug in t equals to 0. So what do you get it out? 2 times 0 plus cos 0, which is going to be 1. When t equals to k, the acceleration is 0. Show that k equals to pi by 4. So dv by dt should be equals to 0. 2 minus 2 sine 2t should be equals to 0. Sine 2t equals to 1. So 2t equals to pi by 2. So t equals to pi by 4. Find the exact value of when t equals to pi by 4. So k value is pi by 4. So for that, velocity will be 2 times of pi by 4 plus cos of 2 pi by 4, which is going to be pi by 2. T is less than pi by 4, velocity is greater than 0, derivative of velocity is greater than 0, t is greater than pi by 4, derivative of velocity is also greater than 0. Sketch the graph of v against t. So this is at pi by 4. So it keeps on increasing, point of inflection. This should be the shape of the graph, 1. Finally, part D, let d be the distance traveled by the particle from 0 to 1. Write down an expression and represent it by the sketch. So d equals to 0 to 1, 2t plus cos 2t dt. So it's going to be t square plus sine 2t by 2 from 0 to 1. When I simplify, it will become sine 2 by 2. And sketch the part. It is the same graph. I am going to get it out. And this is 1. This is pi by 4. And this is 1. Shaded the region. This answer. This is going to be the answer. So that completes the part 2. We'll continue in the part 3 for the remaining parts. See you in the next video. Bye.